Okay. So are there any questions about assignment 1 while we're here? For the most part, everyone did really well. Just want to kind of encourage you to think about assigning things to objects. And part of the motivation for that is that, you know, it helps you not make mistakes. So if you only assign the value of an object once and you use it in your calculations, you won't have to go back and fix things. So just kind of keep that in mind. Okay, so assignment 2. So just in the yes or no, are there any questions about assignment 2 or the hints? Did everyone get the hints? So everyone is cool with assignment 2?
Sorry, I did it like right after class last week, so I'm trying to remember.
So yeah, the one tip that, and I think it was Jessica K who learned this, is to make sure that you set your NA argument for read Excel correctly. And she was nice enough to post a little bit in the Discord about it. I gave you a little hint about that in the in one of the announcements as well. So if you have any other questions about it, like we will usually kind of get done a little early, but I just will like to use that for office hours. So if people just have questions about assignment 2 or assignment 3, that's what we'll kind of do for the last 20 minutes or half hour. Okay.
I actually did have a question about that, the removing the rows,
yeah.
like the NARM. So I understand, like I read the reading about the spreadsheets, like how like they can have missing data and like that sort of thing. I was wondering if when it does that, does it remove the entire row whether or not it has other data in it? Like say if one variable is missing from that row, or how does it like reconcile that?
So usually with na.rm, that's usually an argument to like a function, a summary function such as mean, max, or something like that. So those functions tend to work on single vectors. But like when we talk about tidyr, I think it's either next week or the week after, we'll see that there are functions. There's tidyr complete, which will basically only select complete cases, cases for which there are no missing, that each row has a value, there's no missing values in that row. So when you have na.rm, it's usually applied to like on the vector level. That makes sense.
Yeah, that makes sense. Thanks.
Sure. Any other questions? Did everyone read the spreadsheet paper? Just say yes or no. Did you find it useful? That looks like a lot of you did. So I just find that to be a really helpful paper, just in terms of kind of thinking about how, like, I give that to our collaborators so they know kind of what's easy and what's difficult. So it's kind of a nice paper to like kind of use as like, you know, as you kind of go on and do statistics and you have like, you know, collaborators, it's a nice paper to kind of pass on to them to kind of help make your life easier. So I don't think we'll have much of a discussion about it today, but if there's something that people want to talk about, like, you know, kind of in the middle of class, we'll do that. Okay, third announcement is RStudio Global. So RStudio Global is happening tomorrow. Eric, if you can dig up that link, that'd be really helpful. And again, it's completely free, and you know, it's very friendly overall. So you are interested in R at all, it's a good opportunity to kind of learn. I am pretty sure most of the talks are going to be recorded and posted eventually. It usually takes a little bit, but there's usually lots of fun topics. I'm going to be attending tomorrow, and if there's anything that I think is interesting, I'll highlight particular talks. Okay, so I am, just want to also make sure that everyone is signed up for the tidyverse function assignment. I think last time I was at 14, so please make sure that you're signed up for it. One poll I did want to check. So there's the option of, we can put the class videos up on YouTube as unlisted videos, but I just want to make sure that people are comfortable with that. So if you're comfortable with that, just hit yes. Because I don't want to kind of force people like to share unless they're, or put it on YouTube unless everyone's comfortable with it. So everyone else, are you not comfortable with it? Or if you aren't comfortable with it, hit no, please. Okay. Just kind of based on everyone who voted, I will post the class videos up on each class page, and I need to get Eric access to my YouTube channel, but we should be able to do that, and so you should be able to watch the videos on via the class page. Let's see. We have two people who are going to present today. Bradley and Jessica K are going to be presenting today. So I think we will have them present kind of in the middle of class, just to kind of break things up. But their presentations are going to be pretty cool. Let's see. I think that's about it. I just want to go over some muddiest points that people pointed out. So one person said a little bit confused about how I loaded data. So they used a different method when using RStudio. So there is a file loading wizard in RStudio. When you're getting started, it might be a little easier to use, but it just from like seeing that the setting the NA argument, you can see that there are a lot of different ways that loading data can go wrong. So hopefully the wizard is pretty helpful. I don't really use it, so that's kind of why we cover read Excel, because it is such a useful function. And so there was somebody else noted that read CSV is a little easier to use. So so that's mostly because read CSV has a default argument for NA. So NA is just coded as capital N, capital A for that one. So it's slightly easier to use, but read underscore CSV also has an NA argument. They're read Excel and read underscore CSV are very similar. So we'll be loading some data in with read CSV, I think either next week or week after. So there was a request to learn more about ggplots, so customizing the formats of plots, like colors, text size, etc. So we're going to be covering a lot of that in class today, and I'm going to point you to some resources. There's a really nice workshop that Jessica and Micah did a while ago on kind of customizing ggplots. So I'll point that out in the reading. So someone was asking about this comma notation when you're working with data frames. So this one, so you can see here, the data frame here is called NAMCS, and you've got these brackets, and there's a comma and a 1:5. So what does it do? So I'm going to go over a little bit about the notation, the bracket notation. We're not going to use it too much because we don't, but it can come in handy, especially. So I just want to show people kind of how it works. So when you've got like this bracket notation, so there's actually two sets of numbers that go here. So the numbers before the comma refer to the rows, and the numbers after the comma refer to the columns. So in this example, I'm just getting penguins, and you can see that my 1:10 is to the left of the of the comma. So what is this doing? Or am I pulling out rows, or am I pulling out columns? Yeah, so a lot of people are saying rows. So if you want to kind of grab the first 10 rows, this is kind of way to do it. So sometimes, like I said, sometimes I'd use this. Sometimes I use the head function. But I'm kind of old school, so sometimes you'll catch me doing this. So again, so after the comma, that refers to the column. So if I refer to penguins 1:1, what value is that referring to? And just read the value in the cell. Yeah. So you can see, like, we're at row 1 and we're at column 1. So the value is Adelie. Does everyone see that? Okay, so when you have a missing value, that is your way of referring to the entire row or column. So this one, so there's no value to the right of the comma. So it says penguins 1. And so you can see that this returned the first row of penguins. So again, when you have a blank after the comma, that's referring to rows. So you're saying, give me the entire row, first row of penguins here. So the inverse is if you have a blank to the left of the comma, and that is a way to select single columns of a data set. So here we're picking out the first column of penguins, which if we refer to it as species. So you can see that we're pulling out the species column. So it's all of the species column. So the penguins have 344 rows. So you can see we're pulling 344 rows of the data set. So this is a bit of a jump, but you can see that we can put sequences. So what does 5 to 10 refer to? Am I pulling out the 5th through 10th row or the 5th through 10th column? Yeah, exactly. So rows 5 to 10. And here we're referring to columns 1 to 5. So you can see that we've got 1, 2, 3, 4, 5 columns, and that corresponds to the first 5 columns. Did that answer that the question? Like, again, we're not going to be using this too much, but it is handy to kind of know that this exists. Okay, great. I'm glad that answered the question. Another response, so for loops, just need to practice some more now. So we're going to, so just keep at it. We'll be working with them soon enough, but we're kind of going to go through tidyverse before we get to for and for loops. There was a question about the function presentation, where to upload it. So there is a Sakai submission. So please upload both the HTML and RMD files when you submit, so I can get it up on the website. So there were some questions about using projects in RStudio Desktop. So what I did was I recorded a short video about how to set up projects in RStudio Desktop. We're eventually going to have a session to install RStudio Desktop to your own machine. So we'll get you set up with RStudio on your own computer with tidyverse and everything that you'll need. So we do use RStudio Cloud a lot. It's very handy to get started, but like I know some of you will want to want to transition over to desktop. So there is this video here. Does anyone have any questions about projects while we're at it? And we'll be talking a little bit about kind of the one missing piece about projects in a little bit. Yeah, so I'm glad you found the video helpful, Brady. So this is the one thing about teaching cloud is it is slightly different than desktop in terms of the way it handles projects. I kind of wish they were kind of exactly the same, but that's just kind of the way it is, unfortunately. So just again, thanks for letting me know. So yeah, so I did pass on to Rochelle and Jessica that everyone's wishes that this class was going to be taught before the biostats sequence. So they have heard your feedback, and hopefully we'll start a discussion about it. So I know it's going to take some doing, and at least there's might be an option for students who want to get started in summer. I have the free version of this class, which covers like most of the tidyverse. But yeah, so that might be an option for students who want to get started early. Yeah, make them a combined 8-credit class. That sounds very challenging. As long as I don't have to teach all 8 credit hours. That's a big class. But like, yeah, if we could basically kind of all work together, that would be great. Okay, so that was basically all I had to say about class. So just want to also, if you haven't filled out the week 2 survey and you attended class, please do so. I'll just keep that open, and just remember, just make sure that you're filling out for part 2. Okay, so let's go on to part 3. So I am in, I'll paste the link. So this is where we are right now. So we're going to be talking more about errors. So this is a unit that I think is really important, because a lot of the times when R returns an error, it's kind of understanding what's going on can be difficult. We'll be talking more about ggplot2 and how to customize it, factors, box plots, and talking about dplyr. We'll run over like a couple of the verbs, so filter, select, and arrange. So what I'm going to do is I'm just going to open these slides up into a separate window. So we'll kind of start here. We'll be kind of switching between this and RStudio Cloud as we kind of go on. But the first part about presentation. So the question I get a lot is, what do I do with errors? And a lot of the times it kind of, I feel like people get this kind of error freeze. They're like, oh, I broke something and I don't know, and like, I don't know how to fix it. So let's kind of talk about some general strategies about dealing with errors. So again, thank you, Allison. So this is nice little, so this happens to everyone. This is the process of debugging. Like you're really confident. I got this. And then, oh, you didn't get it. And now you're confused. You're trying everything. Did you try turning it on and off again? And still not working. I have been at number 6, Zon meltdown before. So number 7, never underestimate the power of taking a break or sleeping. So, sometimes that's all you need to do to find an error. And then number 8, you come back and you're all inspired, and then you work at it and then you fix it. So this is kind of the endless cycle for everyone. Does everyone relate to this? Or if this seems painfully like relatable? Yeah. I myself still have these moments. There are like, it still happens, and I make dumb mistakes, and the point is to not beat yourself up for mistakes, just to learn from them. So one thing I want to talk about is talking about understanding the difference between warnings and errors. So a warning is, and I think this is actually really important because some people get paralyzed when R gives them a warning. So a warning is some sort of indication that the data or arguments aren't quite what the function expected. So in a case of a warning, the code is going to run, but you should verify the output. You should make sure that it's doing what you expect it to be doing. So that's one thing to kind of keep in mind. That's opposed to that's different than an error. So an error means that the code can't execute at all given what you have kind of given as an input, both the data and the arguments. And I still to this day, errors can be difficult to understand, which is why Googling is standard practice for errors. So don't feel like, that this is cheating. All of us Google. And I apologize for the formatting, but I was just trying to be cute and highlight all of the R's. So seriously, like the first thing I do when I encounter an error is like I copy and paste it and I just put it into Google. So sometimes there's like, sometimes you just kind of misunderstood the documentation, or the documentation is difficult to understand. So I just wanted to kind of give you kind of an order of operations of places to check. So especially for Tidyverse, RStudio community is a great place to search. Who here has heard about Stack Overflow? And I'll just clear. So a lot of the times you will have an error that other people have gotten. So Stack Overflow can be extremely helpful. But one thing is to learn how to kind of read a Stack Overflow page. Usually when a bit of advice is good, a bunch of people will vote it up. Sometimes advice they give is bad. And so that's kind of the nice thing about Stack Overflow is that it is kind of moderated by everyone. Everyone will kind of give you, there is. So I will say Stack Overflow is a little bit unfriendly to beginners, but at least kind of using it as like a knowledge base to kind of search from, it can be very helpful. So BioStars, if you're doing bioinformatics, so this is kind of the bioinformatics equivalent of Stack Overflow. I found that especially helpful. I don't know how many people in this class are interested in bioinformatics, but that's there. There's also the packages GitHub page. So this can be really helpful, especially there's on the GitHub page, there is a tab called issues. And so usually if you search that, you can see if someone is having the same error as you. This is a little more advanced, but it is still kind of worth looking at. And these will probably come up like in your Google search. But that's just kind of some advice on like kind of, where to look. Because, when you're kind of Googling an error, there are a lot of different sources, but these are some that are especially kind of reliable that I use. Any questions about Googling? And again, so don't feel like it's cheating. I have a really bad short-term memory, and Hadley Wickham, so he's one of the creators of ggplot2. Like he actually has to go into ggplot2 documentation to remember how to do certain things. So if the creator can't remember it, don't you're not expected to remember it. Just try to find the information. Another underrated thing is having someone else look at your code. And this can be especially helpful. So we all have blind spots. So, and someone who hasn't seen the code before, like mistakes can be more apparent to them. So, if you misplace a curly bracket or a parentheses, or you misspelled an object's name, it's always helpful to have someone else take a look at your code. The other bit about looking for errors, and I don't explain this very well, but the error, when you get a bunch of errors, usually the error you're looking for to Google is at the bottom. So there's going to be a bunch of errors generated, but the one you're interested in is usually the last one. And this has to do with how errors kind of get generated in R. So what happens usually is that like if the first error that you make will cause a bunch of other errors. So we call these kind of cascading errors. So when you're Googling and you're trying to find help, look at the bottom error, and hopefully that error will be helpful. There are still some parts of Tidyverse that don't give you a helpful error. So we'll be talking some more about kind of how to kind of verify things along the way. So, most of you have kind of looked at the Discord. if you haven't. Again, the link is on the main Sakai page. Again, I'm just trying to protect the Discord server from other external people. But there are some communities that I just want you to kind of be aware of. So R for Data Science community. So there is a Slack there called r4ds.slack.com. So you can invite yourself here with this link, and it's a really friendly community. So if you need help and I'm not around, that might be a good resource. Again, the RStudio community is also really helpful, but I have found that the Slack, there are a lot of really great people on the R4DS Slack. Okay, so that's it about errors. Is there anything else about errors that people want me to cover? Okay, well, as you kind of continue to go on, you'll kind of encounter lots of different errors. And part of it is just like, be like learning how to learn and learning how to not be afraid of errors. So what I want to do now is I want to go into RStudio Cloud. So I'm just going to go, sorry. So before we get kind of started with the main project, I want to talk a little bit about the here package. And this is the one piece that is kind of missing from talking about a project-based workflow. So take your time. So I'm going to go into the Markdown folder here, and I'm going to open this this R Markdown file called here example. And notice that this isn't in the root folder. We're not in the project folder. So this is just kind of an example to kind of motivate. There's a package called here. And one of the big issues with R Markdown documents is that when you're loading things, it's relative, the relative path is relative to the location of the R Markdown document. And so if you're not in the root folder, that's going to cause a lot of problems for when you're using relative paths. So the worst case scenario would be I started in the root folder and then I had to move everything into a separate folder like Markdown. So all of my relative paths that I worked so hard to kind of get correctly are going to break. So that is a motivation for this package called here. So it's a function that lets us kind of wrap a relative path, and it's going to always give the path. Always going to give the path from starting from the root directory. So here, for example, let's kind of take a look at this code block at 26. So I'm going to load the here package using library here. And so I've got a file in image. So remember, we're in the root folder, and there is a image here called here.png. I should have named it something differently because I realize when you get repeating things, it can be kind of confusing. But if you run this, you'll see that it's not going to give you the relative path to the from the location of the R Markdown document, but it's going to give you the path from the root project. So even though we are in the this Markdown folder here, this is a way to refer to things as if we are in the root of the project. So this is especially handy when you are loading in data. So like, if I wanted to load data from the data folder, for example, here I'm just going to get that graphics file so you can see that we do indeed load the graphics. So this works both. The reason why this is cool, it works both when you are in, when you're just kind of doing things interactively, like what we're doing right now, or whether you're knitting. So just to kind of demonstrate this, I'm just going to knit this document. And you can see that the file knitted, and our image is here, and it just acted as if we were in the root folder. So there's another way to kind of use here. So if you want to provide folder names and like the file name, you can provide them as characters separated by commas. So this is equivalent to that image / here.png. So here it's just image, here.png. I would say that this comes in the most handy when you're loading data. And this is why I really encourage people to use projects. It is just, it removes a lot of these headaches of loading data. Another bonus to using here is that it understands both PC and Mac and Unix style file paths. So any code you share using it will work across all machines, as long as it's in a project. So sometimes you do have to use the set work directory, the set WD function, but here tends to make your life a lot easier. And just again, so here is tied to your current project. And it really only works in the context of a project. So are there any questions about here? It's a little confusing, and I'll be honest, it took me some time to really understand what it's for. So is this clear, or are we just more confused? So not really use it in Markdown. So we'll be looking at that. Just wanted to show you that we'll actually be using it in the Part 3 notebooks. And it will make your life a lot easier as long as you kind of set it up in a project. So let's take a 5-minute break, and then let's just come back at 4 o'clock. If anyone has any questions, just put them in chat, and I'll make sure to answer them when I get back. Oh, and Eric, can you stop recording or pause recording?
Oh, actually, I was going to message you. My Zoom was acting up, so I had to log back in, so I don't have that.
So before we get started, so I just thought we'd kind of split up the presentations. So Bradley or Jessica, would you like to present now, or we can do a unit and like you can present later?
I can do it right now. Sorry, I just took a bite of food real quick.
No worries. I mean, that it happens to me all the time. Okay, so I will stop sharing. Have screen sharing power.
All right. So for my presentation, okay, let's see. Let me pull it over real quick. Okay. All right. Can you see my screen?
Yep.
All right. So for my presentation, I chose to do it on Slice Max. So I'm going to talk a little bit about that and show you what we can use it for. So let's see. So what is it for? Slice Max is a sub-function of Slice. It's similar to the function that we had last week. So like Slice, Slice Max also makes it easier to visualize a data frame by providing a look at what is contained inside. What makes it unique is that it allows us to specify a variable we want to sort by, and then returns maximum values for that variable, and we can specify the number of rows that we want for it. The difference between Slice and Slice Max is demonstrated below in these two data frames. And what I want you to pay attention to here is that you can see that in the original data frame we have here where we used Slice, it just gave us 5 rows. I don't want to say arbitrarily, but basically just did it based on the index. But with Slice Max, it actually gives us the top 5 cars by miles per gallon. So yeah, and that's what it says right here is take note of how the output for Slice Max has returned the rows of empty cars with the highest values for miles per gallon. So this function is similar to its parent function Slice, but fills a slightly different niche. As with Slice, Slice Max is most useful because it can be used with pipes. This makes it easier to pare down and organize a set of data compared to entering just the row and column references. This function can also be combined with other methods of sorting data to produce more interesting results. In the example below, we filter empty cars down to only 6-cylinder cars first, and then we pipe into Slice Max to produce a list of 6-cylinder cars with the highest miles per gallon. And that's what we have here. Notice that it's, so it's much lower miles per gallon because before we had 4-cylinder cars that had a much higher one, and it would be masking these ones. This function is useful for visualizing data, providing users with a tool that can help us better understand the hierarchy of certain variables. It may even provide some utility in organizing and sorting data if used as part of a more complex pipeline like type situation.
Great.
And that is my function.
Yeah, thanks so much, Bradley. Does anyone have any questions for Bradley? Okay, so
sorry if you guys don't. It's pretty.
Oh yeah, so Lisa, you have a question.
Oh no, that was the clapping emoji.
Oh, okay.
Sorry.
Thank you.
So yeah, great job, Bradley. So Jessica, why don't you present? So Jessica is going to present her function.
Just give me 1 minute to bring it
Sure.
up.
No worries.
Can everyone see that?
Yep.
Awesome. So I'm going to be presenting on the geom smooth function from the ggplot2 library or package. So what is this function for? This function helps aid the eye in seeing patterns in the presence of overplotting. Below, we can see a plot from the sample dataset penguins showing body mass in grams by bill length in millimeters. And below, I'm not using the geom smooth function. So you can see my code here without it. And then we get this plot of various data points. And while we can observe a general increasing, positive increasing trend with the length and body mass, it becomes a little bit more clear when we add the geom_smooth function to the code. So here you can see I added it, and then afterward we get this nice little smooth line that can show that our data points are increasing. So without specification of the method in the argument in this function, it'll default to low-s. Low-s is a type of smoothing which is generally done with data points that have less than 1,000 observations, as it can be time consuming to use when there is more than 1,000 observations. And then when there is more than 1,000, it defaults to a GAM method of smoothing. Another helpful modeling function to know is the linear modeling function. And this method will create a straight line or linear fit. And this could be helpful when you're trying to determine if a relationship is linear. So below, I applied that method. You can see it here, the argument in the geom_smooth code. And then when I apply that, we get a straighter line or a linear modeled as compared to the previous graph, which shows a more curvy line. Additionally, without specification of formula, the argument in the function will default to the formula y to x. And if you think that a quadratic function might be a good approximation for the fit of your data, you can go back into the linear model and change the formula to include a squared term. And I provided the example code right there for you guys. However, with the data that we're looking at in the penguins data set, we can kind of see that the linear is a good fit. So we wouldn't want to go back and apply the quadratic. By default, this function also will provide confidence intervals. Since the function is true by default, if you do not want to see the confidence interval on your graph, you can set the SE equal to false as done below to remove the confidence intervals. As you can see, I did it in this code right here. And then we get this nice little graph without confidence intervals, if that's what you would like. And then, is this helpful? I think it is helpful, as sometimes trends can be hard to observe with data points alone. And it is especially helpful when you're trying to understand regressions. And then to learn more about the function, I just included this little tidbit about the question mark and then the function, which you can put into your R console to learn about more of the arguments you can use. And that's all I got for you guys today.
Great. Thank you so much, Jessica.
Yeah.
So any questions? Oh, okay. So Sarah is asking, what is the gray space?
Yeah, so that gray space was actually the confidence interval. I believe that's what you're referring to, right? I can share it again if you'd like.
Yeah, so she's saying yes around the line.
Yeah, so that's just the confidence interval, which you can see without it. When you set it equal to false, you don't get that confidence interval around the line.
So Martin is asking, technically it's the confidence band, not the interval. Yes, so for being technical, it is the confidence band. So yeah, so thank you so much, Jessica. Those were two really great presentations. And again, you know, if you're signed up for next week, I'll be in contact with you so you can schedule a time to meet if you want some guidance about your presentation. So anyways, yeah, so those will be, I'll try to get those up on the site as soon as possible. And so let's go back into part 3. So I'm going to share my screen again. So now I'm going to go from the markdown folder, I'm going to go into the root, and I'm going to go into part 3 now. So I guess I should have started the learning objectives, but these are what we're going to learn about today. So learning about errors and warnings and where to ask for help. So we're going to create and modify both scatter plots and box plots. We're going to split figures into multiple panels using a function called facet wrap. You can customize your plots using built-in themes. And then we're going to get into more of the data manipulation part with the dplyr package. So we'll sort in a variable in a data set using a range, by a variable in a data set using a range. We'll select columns or variables in our data set using the select function. And then we'll filter a data set down according to different criteria using the filter function. So I'm going to skip over the getting help for errors because this is identical to the slides. That's just there for you. So we already talked about here. So, you know, in terms of applying here, so this is kind of how you would use it. So we're going to load in our functions or into the tidyverse and read Excel, and we're also going to load in the here library. So you use here as you can basically wrap the here around a relative path that's relative to the root. So here we want to put we want the data in the data folder first called smoke complete _ complete.xlsx. So instead of just putting data, instead of doing this, which will work right now because we are in the root, our markdown is in the root folder. We want to do this. So we want to just wrap our file path in the here function like that. So let's load it. So Bradley talked a little bit about the pipe. So we're going to talk about this a little later. But what we're going to do is we're going to load a smaller subset of this smoke complete data set. So we're only selecting a certain number of columns from our original data set. So that's what's going on here. We'll be talking more about what exactly is going on in this function here. So let's run this current chunk. For chat is okay. So I have we are now in our Studio Cloud, and so you can see now we have our smoke complete data loaded in. So you take a look at it again by kind of clicking on the data set name and the environment. You can see that we've selected 6 variables from our data set. So we're going to do something with this. So is this, did this kind of answer like how to use here a little more clearly? Or is it still confusing?
So I guess what I was understanding from reading about it before is that you don't have to put the backslashes in. Is that true? Or could you just do data comma smoke complete, or is that?
So you can also do this. And it just depends on your style. I tend to use, that's the way I specify file paths. But if I run this code again, you'll see it works just fine. Did that answer your question?
Yeah.
Okay. Okay, so now we have loaded in a subset of our data. So let's take our the plot that we made yesterday and let's make it better. So Ellison Hill, who used to teach here at OHSU and now is at our studio, she has a great talk called "Take a Sad Plot and Make It Better." And I'm sure not everyone is going to get that reference, and that's fine. It's just I don't expect everyone to get all of my stupid music reference, all of our music references, but that is a Beatles song. So take a sad. Okay, so let's just do a quick review. I'm getting the internet connection is unstable again. So what is mapped to the y-axis? Yeah, cigarettes per day. And we see that we've also mapped color, our color aesthetic to disease. And this is pretty much just our plot that we had yesterday. So if we run it, you can see that we generated, I think this is slightly different because I did disease. I can't remember exactly, but you can see that we kind of generated our plot. So let's start modifying it. So this is the really nice thing about ggplot2 is you can start out with a basic plot and you can basically add different geoms, or you can add customizations to it. So what we can do is we can take our plot and we can just add things to it. So the first thing we might want to do, so there are these kind of built-in themes to ggplot2. So one is called theme minimal. So you can see here our is gray here, whereas it's completely removed here. So this is a very kind of minimalistic way to kind of present data. Sometimes this is a little too busy for some people. So this is kind of just knowing about these kind of built-in themes can be very helpful as a head start. But again, like, you know, you're not limited to this kind of formatting. You can add some customizations on top of this as well. So you may ask what themes exist. So there is this nice link here to this GG theme link, and there's lots of different themes that are kind of built in. So we started out by adding a theme, and those are designated by theme underscore something. So we did theme underscore minimal, but we can directly modify elements of we can take our theme and we can modify it even further by confusingly adding the theme function to it. So notice that this is theme underscore BW, which is short for black and white. And so now we're adding the theme function. So when you're getting started, like if you look at the theme, documentation, it's really going to point out some of the arguments that are really helpful when you're getting started. You're starting out. So axis title, axis.title. So that has to do with both of the axes. If you want to kind of customize that, there's axis.title.x. So that's the label for the x-axis. Axis.title.y. That's the label for the y-axis. And legend.position. So this is a question that I get all the time. Like, I don't like where the legend is, or I don't need the legend, so how do I remove it? And again, like, this is something that you're not expected to know, like, completely offhand. Again, Hadley Wickham, designers of this package, he still forgets how to do it, so don't worry about it too much. So now what we're going to do is we're going to take our plot, and then we're going to add the theme underscore BW. And so we're applying this to this axis.text.x argument. And it's this function that we're using to specify things. And this is an element. So there are 4 kinds of elements, and I'll talk about that in a second. But here we're using element underscore text, and that has an argument for angle, so 90 degrees. So you can see here we have our labels, and they're just kind of flat, as we might expect. But when we provide angle is equal to 90, you can see now that we have rotated our labels. So any questions about that? So here's another tip. So if you wanted to remove the legend, you can give the legend.position argument an argument of none, and that will completely remove the legend. And I don't remember just offhand. This is documentation. You can see why I don't start out with this, because there is a lot of things. But so you can change the position of legends. So there's left, right, bottom, top, or you can use a 2-element numeric vector. So I believe this ranges from 0 to 1. So if I wanted to be on the top, I'm not sure, but let's try it out. Just going to tweak this code. So let's try legend position is equal to 1, 1. I think that's going to put it in the bottom right, but let's see what happens. Oh, so it is a little different. It was in the top right. So let's try 0.75. So you can see that we're placing things at 75th of the width and 75th of the height of our figure. So we can also put it left. So if I change this to left here. To the left of our graph. But when you're using that vector argument, that's more for when you want to position a legend in your graph. So I did mention the elements. So and this is where looking at the theme documentation is really helpful. So, for example, legend position, you can see these are the arguments that it takes. But for example, title, you can use you're going to use element.text to modify it. And if we look at the documentation for element underscore text, for elements, there's element underscore blank. Get an internet connection is unstable again, sorry. And then there's an element underscore rect. So that has to do with anything that's as a border or a background. So you can change properties of that. So element underscore line, that has anything to do with like lines. And then there's element underscore text. So these are the 4 main elements that you use to kind of provide arguments to themes. It's a little confusing when you're getting started, but just kind of take a breath. And oftentimes when I want to learn how to do something, there's no shame in Googling it or looking at other people's code. And that's kind of one of the beautiful things about Tidy Tuesday. which is this kind of weekly data visualization challenge. And people will share their code to kind of come up with these really sophisticated visualizations. So any questions so far about theme?
This one might not be an easy one to answer, but how do you force the legend to display the names in a different order if you would rather have it be in a different order?
Yes.
Is there a way to do that?
So we're actually going to get there. That like I would, that has to do with specifying the factor order, and we'll get there in a little bit. So just be a little patient, and we'll get there. So yeah, that is a #1 question I get all the time, because you can see it by default, it's sorted by alphabetical, but depending on your visualization, you may want people to see like a certain disease first. And so we'll learn how to do that by manipulating the factor order. I did talk about this last time, but I just wanted to show that there are, if you look at ggsave, you can specify things like, the width and the height. So this is in inches, and you can also specify the resolution. So dpi is short for dots per inch. So here we want 300 pixels per inch. So I'm just going to run this. So I want you to look for this awesome plot.jpg in your files and tell me where the location of it. Where did it go? Yeah, it's in the root folder. So if I wanted to save this in the image folder, I could do this. So I'm going to wrap awesomeplot.jpg, and I'm going to add image. So let's run this again. So if I go into the image folder, you can see now I generated it in the image folder. So here's our awesomeplot.jpg. So again, I'm just kind of trying to show you more examples of here. And again, I think it's kind of a slippery concept. Like I think projects and relative paths are still a very kind of slippery concept. So as you kind of go on and work with these projects, hopefully it'll become more and more familiar. So that was a great question, and that leads directly into our next topic. So now I'm on line 165, talking about, we're going to be talking about categorical data. So we looked at a couple of data types so far. We looked at character and we looked at numeric. But categorical data has a special data type, and it's called factor. So for the most part, you can use characters and factors interchangeably for categorical data. But the one main difference is when you want to specify the order in which you're kind of presenting categories. That's the main reason to kind of use a factor. Because again, like with characters, the default ordering is alphabetical. We want any other sort of ordering, we need to use factor. So there's another thing with factors is that they define the permissible values in a vector and with an argument called levels. And this levels argument also helps define the order in which the values are displayed. So here we're seeing, we're starting out with a character vector. So we've got dog, comma, cat, comma, mouse. So The one thing that you can always do, that can be helpful is you can call the table function on a vector, and it will give you a vector of counts. So what do you notice about the order of categories?
It's in alphabetical order.
Exactly. Exactly. Thanks, Stephanie. So what you can do with a character vector is you can actually make it into a factor using the factor function. And you can supply the permissible values, not only the permissible values, but the order with a levels argument. So here, what I'm going to do is I'm going to take our character vector here, and I wrap it in the factor function. And so we're going to assign this into factor underscore vector. And there's that levels argument that we just talked about. And it takes a character vector. And you can see now we specified, these are the permissible categories for this character vector. So dog, cat, and mouse. So let's run this little bit of code, and we're going to run a table on our factor vector. And I want you to tell me what about the order that the factor was presented. So it is ordered by frequency, but do you see how else it's ordered? Yeah, so Bradley, it's in the order that we specified in the levels argument. Yeah, exactly, Sarah. So this is kind of the main reason to use factors, at least in my opinion. I think in week 5, we're going to be working more with factors, but again, this is just to kind of introduce you to the idea of factors and why you would ever want to use them. Because a lot of people, when they kind of encounter this, they encounter this, you're like, what is this for? So that's the number one reason to use factors, is when you want to specify ordering. You're getting an error? What kind of error, Sarah?
It says error in factor, and then it's your code. Object character vector is not found.
Oh, so you make sure that you ran the code at line 175 first. And then it should work.
Thank you.
Mm-hmm. So so let's do a little challenge. So let's take a couple minutes. So I want you to change the order of factor vector to the mouse, cat, dog. And I want you to verify that you did it correctly by calling table. And then when you're done, you can just paste your code into chat. Yep, that looks correct, Lindsay. Yeah, so Jessica, just make sure that your capitalization is correct. I'm not sure if it's going to, because remember, case matters here. So everyone, I'm hearing from everyone that we just change this to mouse, cat, dog. And if we call the table, you can see now our order of our table is mouse, cat, dog. So any questions about this? So again, we're going to be talking more about factors, but the main reason I'm talking about it right now is that we can't talk about box plots without talking about categorical variables. And there are a lot of functions built into a package called forcats, which is part of the tidyverse. that you can use to sort the levels of a factor. And so we will be kind of getting to that in either week 4 or week 5, or part 4 or part 5. Okay. So now let's talk about box plots. So I'm not going to belie this point. I think all of you know what a box plot is, but you're just kind of comparing the distribution of a quantitative variable among categories. So going back into our smoke complete data set, you can see vital status is it looks like it's a categorical vector. So let's plot cigarettes per day versus vital status. So again, we're using ggplot2 on our data set, smoke_complete, and we're mapping our categorical variable to our x-axis. And then we're mapping our numeric variable to our y-axis. And then we are adding a different geom, and it's called geom_boxplot. So you can see now we separated, instead of having one single box for all of the data, we've separated our data out by different categories. So we're looking at the distribution of cigarettes per day by vital status. And if you have missing data, I believe the default is it will show you the missing data. I can never remember this offhand. Or there is an option to remove that category. And I don't remember that offhand, but right now we're just looking at vital status. So any questions about that so far? So again, the main difference from the scatter plots that we made earlier, so I'm now on line 234, is the geom type and the variables we mapped. So we can change the color if we wanted to also color our box plots by vital status. Note that we map to an aesthetic called fill. So it's fill and color. So we're going to color fill the boxes by vital status. So just adding that line, you can see that we now have colored the vital status, colored by vital status. You fill and x-axis always have to be the same. No, they don't. It will look a little. Oh, interesting. Okay, so you can see now it's separated out. So that's kind of the default behavior. Oh, sorry. So like we changed the fill to gender, and you can see our alive and dead categories are further split into male and female. So yeah, I mean, it can be really helpful. And again, part of like being really good with like communicating with your visualizations, I think, is very carefully thinking about the role of color. And I just realized that I didn't really talk too much about how do you change like the internal colors here. But I will have an example next time about doing that. Categorical variables, there is a function called scale. I think it's called scale. On this, it would be scale x discrete, because discrete is another way to refer to categorical variables. But I'll have a more clear example of that, so like you can kind of play with that. There's also a lot of really great color palettes that are built in or that are available as packages. So one of them, and I'll have more examples about this. I should have had more examples about how to kind of customize color, but there is a package called Wes Anderson, which I really like. So this guy, he's part of this group called the R Open Sci, Karthik. He loves Wes Anderson, so there are all of these different color palettes that are kind of derived from the different Wes Anderson movies. So these are fun. I know. I'll post the link to this in chat. So in case you want to take a look at this. So these are, it's just kind of fun. I know Lisa Karstens is really, she really likes the Isle of Dogs. I think it's Isle of Dogs one, but so we'll have more examples of like, you know, customizing colors next time. So, okay. So we saw that by kind of changing our fill variables, we could split the data out further by category. So this can be useful, but I would say one of the most powerful ways of have alive and dead on the x-axis, but there would be two separate plots for gender and female.
You're cutting out a whole bunch. We're losing you frequently.
Okay, so I am going to try switching my network. Things might go a little pear-shaped. So Eric, can you pause recording? About faceting again. So apologies for those people who could hear me. So we talked about basically, you know, when we mapped our fill to a different variable, you can see that we generated side-by-side box plots by gender. But another way to kind of present this data is by what's called faceting. So by faceting, if we facet on gender, what we would have are two separate graphs, so both of them would have alive and dead categories, but they would be separated out by gender. So we would have a female graph and we would have a male graph. So how do we do this? So we add this additional command called facet_wrap. And there is another one called I'm going to kind of focus on this one for right now. And maybe I'll have more examples of that in this a little bit. So, okay, so you can see that we basically, this is our same code. I added this additional function. So when you want to set limits, there are these functions called xlim and ylim. So you can change the range at which you're plotting something. And now I'm adding this additional function called facet_wrap. I wish you could just type in disease here, but unfortunately, the way facet_wrap, you have to wrap disease in this vars function. If you try to do it, you're going to get, without the vars, you're going to get an error. And I'll show you an alternative way to specify this. So now we facet wrapped, and we're faceting by disease. And so you can see now we generated the faceting we've got bladder cancer, cervical cancer, and lung cancer on separate graphs. So what do you notice about the scale, the y-axis for all of these? Yeah, they all have the same scale. So like when you're comparing things, like this is really like across categories, this is really your friend because it makes patterns and distributions very apparent. So Colin was talking about and I did mention there's an alternate way to specify this. We haven't gotten into formulas. So you can also use this tilde notation. So tilde disease. And that will generate the same thing. And this tilde, this is called formula notation. So we won't see it just yet. It is an option to kind of specify facets. So any questions about facets?
Do you know if that same vars function works with grid arrange? Possibly.
I'm not sure offhand. Are you talking about facet grid, or are you talking?
Like the grid package, I think we used it in our other class. Yeah.
Yeah, I don't know that offhand. I mean, the short answer is that ggplot2 is built on grid, so it may inherit a lot of the. You may be able to do it, but I can't. I couldn't tell you right offhand.
Okay, that's all right. Thanks.
Yeah. So if you find out the answer, let me know. But so in general, I don't think you can use a lot of ggplot2 functions with grid because it's kind of built on top of the code. Okay, so now I want you to do the challenge.
Really quick, is the faucet function, the faucet wrap function, only used on boxplots?
No, you can use it. So this is it. So we can. This is what I like about teaching this part because we can do. So let me add a facet. So I'm going to facet wrap and then by disease here. This is a good question. So you can see now we faceted our scatter plot by disease. So you can see this is like a really powerful way of kind of visualizing your data and getting to know your data. And you can customize these again with a theme argument.
That's super cool.
Yeah. So that's a really good question. So sometimes I just apply a function to one thing, but a lot of these things that I'm showing you, they can be applied to almost any ggplot code that you make, especially faceting. So I want you to do the challenge on line 279. So what I want you to do is facet the box plot by gender and paste your code into chat when you're done. Yep, looks like people are getting it. Again, you can wrap gender in bars, not genders. And we run this code. You can see now that we have faceted by gender. Yeah, great. So you can see this is just kind of, this is a tour of some of the really powerful functionality of ggplot. Again, I will come back next week with more examples about customizing. But in case you are interested in learning more, I would say the number one thing is to check out the ggplot cheat sheet. So these links are also available in the slides as well. Or no, it's actually available in the part 3 reading. So if you want to kind of check these out, I might as well show those. So these are kind of the different kind of cheat sheets. So this is kind of the one that's from RStudio that can be helpful. I really like this customizing ggplot2 cheat sheet because it organizes things by task and not by function. And I'll show you what I mean by that. So for example, like you're not necessarily going to know the name of the function, but you might know that you want to do something with it. So here, it's kind of categorized and like it's kind of organized by things that you do most commonly. So like, for example, I want to turn off the legend title. So this is a really handy reference. I just try to point you to as many kind of resources. So as a bonus to the assignment 3, so Jessica and Micah, I think I mentioned this before, they have these, is there a question? Sorry. So they have these great slides they did for a bird workshop. This takes a second to load up because it's kind of big, but this is also a wonderful, and there's a PDF version too if you want a separate PDF. What I really like about what they did, they have this visual table of contents, and they try to show you as many different kinds of plots. But the neat thing about this is, so it's in this flipbook format, so you can see how they build it. So here we're starting with this data set. Now we're mapping our X aesthetic. We're adding a geom. We're adding a fill. We're adding labels. So I just really like this. I love this format for teaching. I wish I had more time to kind of teach ggplot2, but this is a great resource. So I do say as a bonus, so if you want to pick one of those geoms and make a graph, kind of using that from their presentation, I highly encourage you to. Okay, so we are at 5 minutes till. So let's take a short break, 5-minute break, and come back at 5, and then we'll jump into the dplyr package. So Colin had a question. So you may, what is the difference between using AES as an argument of the ggplot function versus outside? So when I teach ggplot2, the main reason I teach it this way is that it separates out the different components of ggplot2. I mean, the short answer is I do it that way to kind of make it easier to see what each of the components is about. But if you look at the ggplot documentation, so there are a couple of arguments to the ggplot function: data, and then there's mapping. And you can provide your mapping as an argument by wrapping it up in the AES function like we've seen. So this code will work. And so you can see that it's not a really good plot. It's because there's a lot of overplotting, but we did a geom point. So in short, the short answer is there's not much of a difference unless you're adding multiple geoms and you want an aesthetic to only apply to that geom. So what I'm going to do, so you see we have a geom point here. I'm going to add another geom called geom text. And so you can see I've included an aesthetic mapping. So I'm mapping label equals gender and then color equals gender. So this aesthetic mapping is only going to apply to this geom. And again, this is not a very good plot because I had to come up with this on the fly, but you can see that the points are not colored and the text is colored. Did that answer your question, Colin? Okay, great. So I'm going to cut and paste this code into chat in case you want to play around with it. So that's an entire code block. So so that's the short answer. So you can use this shorthand notation, and a lot of people do. But I've just kind of like, I learned that from Gina Reynolds. She's the one who came up with the flipbook idea. And it's just, to me, it just makes things very clear. And it's just it's easier to teach. Okay, so let's start. Now I'm on line 317, data manipulation using dplyr. So what we've learned is it's pretty great for plotting, but there's a lot of other things we can do with data frames. So this is like as you become a data ninja, and yes, that's a professional term. As you become a data ninja, you need to start manipulating data. So dplyr is your all-purpose toolbox for doing things like filtering data, summarizing data, and transforming data. And transforming could be like, you were given like the numeric variables as integers and you wanted to recode them as different categories. So that's kind of the level on which kind of dplyr works. So what I like about teaching dplyr is it's really like it's verb focused. So you do things to data. So these are kind of the 6 kind of main kind of functionality that we're going to kind of talk about. So we'll be talking about the first 3 today, and then we'll be kind of going in these 2 tomorrow, next week. And so you can see that arrange, so there is arrange verb, so that arranges or sorts a data frame by a variable or multiple variables. There's a filter function. So Bradley showed an example of filter, but we'll get more specifically into that. So it's subsetting a data frame by some sort of criteria. And Bradley's example was he wanted to only get those cars in the MT cars data frame that had 6 cylinders. Select. So this is for returning only a few columns from our data frame. We saw an example earlier, but we'll get more into this. Group by and summarize. So these usually go together. So these are kind of functions that let us summarize our data frame. So we can do things like count the number of within a category, or we standard deviations, medians, all sorts of things with that based on a particular categorical variable. So mutate, we'll get into that next week. That's for the transformation. That's the one. It's like obvious what it does. Can people still hear me? I'm getting an internet connection's unstable.
So far, yeah.
Okay. And then this is actually what we're going to start out with. So we're going to start, Bradley had an example of this, and I've just kind of been dancing around this, but this is called the pipe character. And so the pipe character, it takes a little getting used to, but once you get used to the idea, it becomes a very powerful way to kind of chain these verbs together. So now I'm on line 338, introducing the pipe. So the pipe is signified by this percent greater than percent. And the reason why we want to do this is we might want to do multiple operations on our data, and we might want to do these multiple operations in a specific order. So again, much like ggplot2 statements, I want to kind of take you through reading how you read out loud a dplyr statement. So let's kind of talk about it verbally. So we want to take a data set such as smoke complete, and then so notice that this I've highlighted this, and then we can sort it by the cigarettes per day category variable, and then we want to filter it to only contain males from the data set. So notice that I highlighted and then. So the pipe is basically, it's kind of a connector between all of these operations. And I always read it as and then. So let's go through an example here. So now I'm in this little code block. So we're going to take my data set smoke complete, and then, so remember this our pipe character maps to and then. And then we're going to sort it by cigarettes per day. So that's the arranged variable. And then filter it to only have males. So what's going on underneath it is that you're basically kind of you're applying a verb, and you're producing an output, and you're using an output as the input data set to the next function. So you can here we're going to do smoke complete. We'll pipe, and then we'll arrange by cigarettes per day. So this is equivalent to this function, cigarettes per day. So the short answer is that the way it works is it's always we're basically taking the first argument. The first argument is always assumed to be the output of the pipe. So here, basically, we're doing the same thing. So the first argument for arrange and all of these functions is always the data, and then it's the variables that we want to sort by. So is everyone thoroughly confused? Okay. Yeah, I mean, it's like, again, like many of these concepts, I think it looks a little weird when you're first starting out with it, but once you start using it, you begin to realize how useful it is. Okay, so why would we do this? So this statement is a much easier thing to understand than this statement. So again, we started with filtering. Oh, I did that backwards. I apologize. This should be a range. But here we're starting with smoke complete and we're filtering it. And we're using that as a first argument to a range. And so if I had to do multiple levels of this, you could see how this could get really, really ugly. So the real strength of the pipe is not just using it for one or two commands, is that you can chain like 10 dplyr verbs. And you don't have to kind of write this nested structure. Yeah, so, and this is really stuff that I feel like people, before you even start the stats course, I spent a lot of time thinking about what you really should know before you even get started with this. So, yeah, I mean, it is extremely frustrating when someone shows you code and like there's parts of it that you don't understand. So I will pass that feedback. I'll pass that feedback on to, I'm sure like Rochelle is going to get sick of me, but I will pass that feedback on. I mean, and hopefully, you know, this part of this course at least will hopefully come before all the stats course. So hopefully this will be, your opinions will save the next of students. Yeah, so one thing that I want to kind of emphasize is that you're not going to write like these really long chains all at once. So this is, we saw the view command before, so now I'm on line 398, one step at a time. And so I say I want to kind of verify the output, that it's arranging things the way I expect it to. So I can write my statement kind of one verb at a time, and I can pipe the output into the view function. The function will let us kind of see a spreadsheet-like view. So let's run this code. So I'm piping smoke complete. I'm arranging by the cigarettes per day variable, and then I am going to view the results. So how is cigarettes per day sorted? Yeah, so it's sorted in ascending order. Exactly. So if I wanted to add my filter statement, so let's add filter. Gender, and we'll get more into the double equals in a second. And then I'll pipe that into view. So you can see now we have, we can confirm that our subset of the data now only contains males. So this is a trick that I kind of learned the hard way, so I am passing this wisdom on to you. But you can also, of course, you can also just run the code directly and you can examine it. You can examine the data that way. But I often find that this is a good kind of way to kind of plan things out. So sometimes I don't know what the right order is of operations. So should I arrange first and then filter? Although that doesn't matter, but there are certain verbs for which the order in which we do an operation is important. Yeah, so hopefully that makes your life a lot better, Natalie. Okay, so, and like I said, that's how I work. So this, using the view command, I find that to be like a really helpful tip. And okay, so I'm getting a question, how do I know when order will matter? So we can talk more about that. And in general, it tends to be like with filter steps. So thinking about the order in which you're filtering the variables by, I would say that's kind of the #1 gotcha. So for example, if I filtered by stage 1, stage 2 cancer and filtered by male second, that would be different than filtering by male first. That's not a good example, but there are examples like that. So I'll try to think of one. Okay, so the difference between so this is one thing, and again, this has to do with kind of contexts, is the difference between plus and the pipe. So I kind of wish like it was all just a pipe, but ggplot2 came before dplyr, so that's why the plus. And like if they changed this, basically a lot of code would break in the world because a lot of visualizations are built on ggplot2. So what I do to avoid getting confused is that I will do process the dplyr steps first, and I will assign that into a new data set. So here where you can see that I'm using taking smoke complete, and I'm filtering it to just males and assigning it into the arranged _ smokers. And then I take that data set so the equivalent you can also do this, but I just find this really confusing. So you don't, again, because the first argument is the output, so you can chain things together like this. But I find that I make a lot of mistakes because I forget where to put which part of the statement uses pluses and which part of the statement uses pipes. So this is just my own kind of tip. If you don't get confused, it's great. You can use this method, but this is just kind of another tip. Especially and I just kind of like it because I can verify the data set is correct, and then I can do the plotting. So any questions about the pipe? Okay. So now let's actually start working with the dplyr verbs. So we've talked about the pipe, and we've used arrange several times, but let's learn to actually use it. So again, arrange is a function that lets us sort a data frame by a variable. And by default, as we already discovered, it sorts in ascending order. And depending on whether it's a character or a numeric, it's going to sort differently. So if it is a character, it's going to sort in alphabetical order, ascending. So let's just run that on smoke complete. So we'll arrange. So you can see this is a person who smokes the least number of cigarettes per day, and it just gets larger and larger as we kind of continue on down our data frame. So to sort by descending order, which is usually I would say most of the time a descending order is usually the most useful order, but it is not the default. So to do that, we need to wrap the variable with the DESC function. So now let's run this. So you can see now that this is the top smoker. Wow, 40 cigarettes per day. That's amazing and unfortunate. So you can see now that we've sorted by the in descending order. Any questions about that so far? Okay, so you can also arrange by multiple variables. So you can see we're arranging first, arranging by descending order of cigarettes per day. And then within cigarettes per day, we're sorting by tumor stage. So we just added a comma to the end of our arrange statement, and then just added tumor stage. So you can see that we first sort by cigarettes per day, and then we're sorting order. And again, the default order is ascending alphabetical. So this is okay. So this is one case where actually the order matters. So this is we're arranging by cigarettes, descending cigarettes per day, and then by tumor stage. But let's do the opposite. So let's arrange by tumor stage and then by descending cigarettes per day. So again, okay. Well, unfortunately, it starts with tumor stage, not reported. But let's go down. So you can see now we're started with stage 1, and it's going down in descending order. Okay, so this is a challenge. So when you're done, just paste the code into chat. So use arrange to sort by disease and then by descending tumor stage. And I'll be right back. I need to find my water. Yeah, so, okay, looks like everyone. Okay, so Lindsay, be careful with your nested parentheses there. If I think, yeah, so remember, so arrange, we want to have that, it's going to be arrange, disease, comma, EESC tumor stage, and then you'll have an extra parentheses at the end. Yeah. And again, you know, but like, again, this is kind of the power of having someone else look at your code. So where do you put view, Sarah? Okay, so let's so you put view at the end. Because you're always looking at like the final output. So let's just kind of fill this in, disease. And then descending, so we need to DESC, tumor stage. And then we'll pipe it into view. And so now you can see that we arranged first by disease. So it starts with bladder cancer, and then it starts with stage 4, and then it goes down. Yeah, so that's the, and Sarah, that's a mistake that I make all the time. And like view will be like, I don't know what you want me to view. So okay. So look, now we're getting into more powerful stuff. We're getting into filter now. So now I'm on line 487. And this is, again, this is an extremely powerful function. So we can query our data and we can subset it according to specific criteria. So again, we're using our pipe and we're piping it into filter. And now we can add our criteria. All of the patients who smoke less than 20 cigarettes per day. And so you can see that, well, we're not sorted, but like just kind of by cursory inspection, you can see that we have now subsetted our data. So our original data set had 11, wow, that's not a really good, let's try a different number. Let's try 5. So our original data set had 11,152 rows. So let's go for an example that makes it smaller. So you can see that our subset is now smaller. So 1,060 is smaller than 1,152. So we can also filter on a category, but it's slightly, the notation is slightly different. So you can see here that we used greater than. So you can also use operations like greater than or equal to, or less, sorry, I mean less than, that's less than or equal to, and then or greater than and equal to. And if you just wanted those people who smoked just 5 cigarettes per day, only those people, you can use the double equals. So when I'm writing code, this is like the #1 mistake I make is I put 1 equals here in my filter statement. So, and you will make this mistake often as well. But just, you know, if your filter statement is usually this tidyverse is nice enough to let you know. So let's look at the bottom error. So it says this usually means that you used equal sign instead of double equal sign. Did you mean cigarettes per day? Double equals 5. So usually that's an example of a very helpful error. And again, I make this mistake all the time. So we can filter on a category. And here we're using the tumor stage variable, and we know the values of that categorical variable. And I'll show you a quick way to kind of get values out of a categorical variable in a second. So any questions about filter so far?
Can you have multiple conditions?
Yes, and we're just getting to that. So, and the key with multiple conditions is thinking about the logic of and the order. So one way to do that is you can just add another filter statement. So if I said filter gender equals male. So this is like when you're kind of, you know, this might be a good way to, like, if the logic stuff gets a little confusing. This is what is called an and. So everyone see that first we're filtering by tumor stage is equal to stage 4, and then filter by gender is equal to male. So you can see that our filtering, we only have 75 patients now, and that we've got males and tumor stage 4. So in general, that's usually what you want to do. You just get where it's difficult to understand is when you want and you wanted people that satisfied either of those conditions. So that's where we get into the and or operators. And these are signified by the ampersand. And unfortunately, the word for this character is also called the pipe. This is the Unix pipe. It's usually if you capitalize or you hit Shift \, that's how you get that. You get that character. So this is, and you could think about this like, if we were recruiting patients and we had recruitment criteria that like the patients could either be, over 65 or have stage 4 cancer. That is different than if we wanted patients that were over 65 and had stage 4 cancer. So if we wanted to return the patients that have both of these criteria, this is how we specify this. We basically have our two criteria and we chain them together with the and. So you can see now we return 75 rows. So what if we wanted to return patients who were male or had stage 4, had a tumor stage of stage 4? So just like intuitively, would you think that this subset is going to be bigger or smaller than the and set? Okay, so I am getting bigger. Thanks, Eric. So can someone just remind me to turn off recording at the end? That would be really helpful. So let's try it. So here we have gender is male or tumor stage is equal to stage 4. So you can see we have 802 rows. That's a lot larger than 75. So I will tell you that, I mean, in this, the work I'm doing right now, this is, figuring out who kind of to include in a study with the inclusion criteria when you've collected on a larger data set. This you will go back and forth with this a lot. And this sometimes keeps me up at night, making sure that I subsetted my patient cohort correctly. So it's just something that you will kind of encounter as you kind of work more and more with data sets. So any questions about this? And I would say, usually most of the time you want the and case, but I did want to show you, if you did have the or case, whether that would be that's a particular option. Okay, so I kind of magically knew, so now I'm on this line 551. So how do I know what values exist in the categorical variable? So we've already seen a couple of tools that we can use for this. So we've seen that both skim and glimpse can give us an idea of what values exist in the categorical variable. So one other way to do it is to use distinct. So distinct, this is a verb that I don't use all the time, but sometimes this can be really a handy way to get all of the values for a categorical variable. So I'm saying I only want those values that are distinct, and of tumor stage. And then I want to arrange by ascending the tumor stage variable by ascending. And so you can see distinct only returns that the column that we're interested in, and it returns a data frame and it's sorted. So this gives us, you know, this is like a quick and dirty way to kind of figure out what are all of the permitted values in the data set. So any questions about that? Oh, and this is also really handy, and I encounter this all the time. So for example, like someone might have encoded this as stage 1 with a numeric 1 instead of like the Roman numeral I, 1, I. So that's one way to kind of find this out. So the other way to do this, and this gives you some additional kind of statistics, additional kind of summaries on the data set, is to use this function called table, but it's spelled with a Y, T-A-B-Y-L. And this is from the janitor package. And you can see that this is kind of handy because it gives us the breakdown and the proportions of like those categories in our data set. Okay, so I think this is the final challenge of today. So I want you to use filter to select patients who have disease, the lung cancer patients, and who smoke less than 1 cigarette per day. And then paste your code once you are finished. Okay, so Farzana, so that looks good except for your logic operator. So do you want to use or do you want to use and? Okay, so it seems like most people got this. So there are 2 ways to do this. So because we want an and, we can do it this way. So use 2 filter statements. So you can see that returns 60 rows. Or I'm going to delete the filter in the pipe. Parentheses here. And then I'm just going to put an and here. So those are, I think everyone got that solution. So yeah, just be very careful that you are using the and not the or in this situation. So just more about comparison and logical operators. So this is a handy reference that kind of lets you know all of the different kinds of operators, both logical and comparison. So I think the most important ones are basically and, or, and not. Don't worry about things like XOR. I have to teach myself what that means every time someone uses it, and it's mostly useful in computer science and nowhere else. I tend to make these grandiose statements. Maybe that's not true, but I have never really used exclusive XOR, or which is short for exclusive OR, in my chains. great. So it seems like everyone got the filter statement. So this is the last bit of code that we'll talk about today. So we'll talk about select. And I guess if now that I think of it, I might put select a little further down because it seems like it's doing the same people, but instead of selecting rows, we are selecting columns. So here we're going to take our smoke complete, and we're going to select the gender and tumor stage variables. So you can see now that we only have 2 columns in our data set now. So that's and I often use this, because the data sets I'm given, they may have like 100 different variables, but there might be specific questions that I only want to look at 3 or 4 variables. So that's like the #1 reason I use select. So now we're kind of on this section around the code block at 6 to 11. So if you want to select everything but one variable, you can put a minus in front of that variable. So we've got 6 variables. So we want everything but gender. So we expect that there should be 5 columns in our data set. And as expected, you can see that we have everything but gender. So that's kind of the main use for select. I am giving a talk, and this is for the more kind of advanced students. So there is actually a system in the tidyverse called tidyselect. And you have there is this kind of, you have this tutorial that I've written that's built in to your project. So you can just run this code and it will pop up the tutorial and you can kind of learn about this. This is a little more advanced. So it's completely optional, but this is, I'm trying to put together a set of tutorials for kind of intermediate level students. So that's just an option. I'm also going to talk about this at the PDXR user group tomorrow. Hopefully I'll record it. I'll also send information out if people want to come to that. Okay, so we're almost done. So I just want to drive home, and again, I get this confused all the time, but the difference between filter and select. So filter works on rows and select works on columns. And actually, I think I actually had a nice, so I'm just going back into classes. So in part 3 in the presentation, actually have a nice kind of, and this is directly from the the dplyr cheat sheet. So this is filter. So you can see we're reducing the number of rows, and then select, we're reducing the number of columns. Any questions? So the last thing we're going to do is we're going to save our results. So we selected everything but the gender column, and then we filtered by cigarettes per day. And we're assigning it into our process data variable. So there is a function that writes comma-separated values that are files that are compatible with Excel. So if you wanted to open this up in Excel, you can do that. So here we're using this write_Excel CSV. function, and we're running it on, we're providing it our processed underscore data. And here we're providing, sometimes the file name is called path, the argument for file name. And so here I'm going to wrap it in here, and it's going to end up in our data folder. Yeah, I'm glad you're finding this helpful, Stephanie. Like, it takes a little time to kind of wrap your head around, but like, you know, it helps you, like the base R way of doing this is very clunky. And once someone showed me this, I was just like, well, I still use base R every now and then, but tidyverse for a lot of projects is like the way to go, in my opinion. So here, I'm just going to run this. Oh, okay, so now they want me to use file. So that should be file. But it will still work. So this is a real example about a warning. So like, you know, it says a warning, the path argument. So it's like with readr, the new version of readr, it says please use the file argument instead. So if we run this again, no error, no warning. And you can see in our data folder, now we have that process data.csv file. So this is what you learned today. So we talked about ggplots and customizing them using themes. We talked about factors, box plots, and faceting plots. We talked about the pipe character, and arrange, filter, and select. So here I just don't want, so please remember to fill out the survey. Again, I will, you know, I hope you filled out part 2. So please fill that out when you have a chance. And then, you know, again, this is the free, kind of one of the free versions of this course. So if you want to practice doing some plotting, so there are chapter 2 and chapter 3 in the R bootcamp are some good places to practice. So Kate, Jessica, and I put this together, and it's all kind of from previous workshops. So like I said, like I will let people go if they want to go. If you want to work on assignment 2 or an assignment 3, and you want just some help, I will stick around. So anyways, thanks everyone for coming, and I am going to stop recording.